Almost every new gadget, from phones to laptops, now features a small, reversible oval port. This is USB-C, and it promises to simplify our digital lives with a single, universal connection. But the truth is, beneath that simple connector lies a labyrinth of competing standards and capabilities that can make choosing the right cable feel like a guessing game. By the end of this video, you'll understand exactly how USB-C works, why it's revolutionizing connectivity, and how to cut through the confusion to pick the perfect cable for any task. First, we'll demystify the crucial difference between the physical USB-C connector and the powerful, evolving protocols it carries. Then, we'll explore how this single port unifies data transfer, high-resolution video output, and smart power delivery, making it the true king of universal connectivity. Finally, we'll expose the common pitfalls and marketing jargon that lead to confusion, providing clear steps to ensure you always have the right USB-C cable for your needs. The era of a single cable for everything is here, but its path isn't as straightforward as it seems. Let's unpack the reality. The journey begins by understanding that USB-C is fundamentally just a shape. It's the physical connector, the reversible, symmetrical port that fits no matter which way you plug it in. This design alone was a massive leap forward from the days of micro USB, mini USB, and the various rectangular USB-A connectors. It's smaller, more robust, and significantly more user-friendly. However, the common misconception is that USB-C is the technology controlling data speeds, video output, or charging capabilities. That's simply not true. Think of the USB-C port as a multi-lane highway, but the actual speed limit and what kind of vehicles can drive on it are determined by the underlying protocols. These protocols are the real engines behind USB-C's versatility. They dictate whether your cable can charge a laptop, transfer gigabytes of data in seconds, or output a 4K video signal to an external monitor. And this is where the complexity and the incredible power truly lies. The primary protocol most people associate with USB-C is naturally USB itself. For decades, Universal Serial Bus has been the backbone of peripheral connectivity, but the USB standard has evolved dramatically. We started with USB 1.0, then USB 2.0, which is still surprisingly common in basic USB-C cables and accessories, offering a maximum theoretical speed of 480 megabits per second. This is fine for keyboards or mice, but painfully slow for transferring large files. Then came USB 3.2, which dramatically ramped up speeds. USB 3.2 Gen 1, often marketed as Superspeed USB 5 Gbps, delivers up to 5 gigabits per second. USB 3.2 Gen 2, or Superspeed USB 10 Gbps, doubles that to 10 gigabits per second. And the more recent USB 3.2 Gen 2 times 2, sometimes called Superspeed USB 20 Gbps, pushes it to 20 gigabits per second by utilizing both sides of the USB-C connector for data transfer. Keeping track of these names is already a challenge, let alone knowing which one your cable actually supports. But the story doesn't end there. The most significant leap in the USB lineage is USB 4, introduced in 2019. USB 4 is built on the underlying Thunderbolt 3 protocol, meaning it natively integrates Thunderbolt's capabilities and offers speeds of up to 40 gigabits per second. It allows for dynamic sharing of bandwidth for data and video and can drive two 4K displays or one 8K display. The latest iteration, USB 4 version 2.0, announced in late 2022, promises an astonishing 80 gigabits per second, doubling the bandwidth of USB 4 and even reaching 120 gigabits per second in specific configurations for high-performance displays. This is where USB-C truly becomes a unifying force, capable of handling almost anything you throw at it. Beyond the USB family, the USB-C connector also supports other powerful protocols, most notably Thunderbolt. Developed by Intel and Apple, Thunderbolt ports physically look identical to USB-C, but they offer guaranteed higher performance for data, video, and power. Thunderbolt 3, which was open-sourced and became the basis for USB 4, offers 40 gigabits per second bandwidth, supporting external GPUs, multiple 4K monitors, and high-speed storage. Thunderbolt 4 maintains the 40 gigabits per second speed, but raises the minimum requirements for video and data, ensuring better consistency. And the newest Thunderbolt 5, announced in late 2023, promises up to 80 gigabits per second bidirectional bandwidth, with a burst mode up to 120 gigabits per second, mirroring the advancements in USB 4 version 2.0. This means a single Thunderbolt 5 cable could potentially drive three 4K 144 Hz displays simultaneously while also transferring data and charging your laptop. The ability of USB-C to carry these protocols is what makes it so revolutionary. USB-C isn't just for data. It's designed to be a true all-in-one port. One of its key capabilities is the DisplayPort Alt Mode, or Alt Mode. This allows USB-C to directly transmit video and audio signals using the DisplayPort standard, meaning you can connect your laptop or phone to an external monitor or TV with a single USB-C to USB-9 Vangsted or USB-9 to HDMI cable, eliminating the need for separate video outputs. Imagine a sleek laptop with just two USB-C ports, yet it can connect to a docking station that powers the laptop, connects multiple high-resolution monitors, and links all your peripherals, all through one cable. This is the promise of USB-C, realized through DisplayPort Alt Mode. The other crucial component is USB power delivery, or USB-PD. Older USB standards could only supply small amounts of power, near typically 2.5 watts for charging phones. USB-PD changed that dramatically. It's a specification that allows for flexible and efficient power delivery over USB-C, enabling devices to negotiate power levels. This means a USB-C cable can charge anything from a small earbud under 1 watt to a powerful laptop up to 240 watts. The magic of USB-C charger could theoretically charge your phone, your tablet, and your laptop, adapting its output for each device. This smart power negotiation is a game changer for reducing cable clutter and charger waste. With these protocols combined, USB sending transforms into a truly universal connector. A single cable can now connect an external SSD for lightning-fast data transfers, power a high-resolution monitor, and charge your device all at the same time. This convergence has made it indispensable for modern computing, allowing for extremely thin laptops that don't compromise on connectivity, or powerful docking solutions that require only one connection to your host device. Consider a professional who travels frequently. Instead of carrying multiple chargers, video adapters, and data cables, a single high-spec USB-C cable, paired with a compatible hub or docking station, can handle all their needs from presenting on a projector to connecting to a hotel's internet via an Ethernet adapter. This level of versatility was unimaginable with previous USB standards, but this incredible versatility comes with a significant catch. Not all USB-C cables are created equal. This is the most common mistake users make. A cheap USB-C cable might physically fit your port and only support USB 2.0 speeds and minimal power delivery. You could plug in an external 4K monitor and get no signal, or connect a high-speed SSD and find it runs at ancient USB 2.0 speeds. This isn't a fault of USB-C itself, but a lack of understanding regarding the underlying specifications. The market is flooded with cables that look identical but have vastly different capabilities. Another common pitfall is misunderstanding power delivery. Just because a cable supports USB-count doesn't mean it can handle the wattage your laptop needs. If your laptop requires 100 watts and your cable is only rated for 60 watts MR, it simply won't charge, or it will charge very slowly, leading to frustration. Similarly, confusing USB-C with Thunderbolt is a frequent error. While all Thunderbolt 3, 4, and 5 ports are physically USB-C, not all USB-C ports are Thunderbolt. If you buy an expensive Thunderbolt SSD and plug it into a non-Thunderbolt USB-C port, you'll still get data transfer, but at significantly reduced USB speeds, losing out on the performance you paid for. The marketing jargon doesn't help either. Terms like super speed or even USB 3.2 Gen 1 can be vague, as manufacturers often prioritize making their product sound fast over providing clear specifications. So, how do you navigate this landscape and choose the right cable? The key is to always check the specifications, both for your device and for the cable itself. Look for clear labeling. Reputable cables will indicate their capabilities with symbols or text. For data speed, look for USB 3.2 Gen 2, 10 Gbps, USB 4, 40 Gbps, or Thunderbolt 3/4/5, 40 Gbps, or 80 Gbps+. For video, ensure the cable explicitly states it supports DisplayPort Alt Mode or video output. For charging, look for the wattage rating, typically PD60W, PD100W, or EPR240W. Cables certified for Thunderbolt will usually have a lightning bolt symbol. If a cable is missing these specific labels, especially for power or high-speed data, assume it's a basic USB 2.0 cable. It's always better to overspec your cable slightly than to underspec it. as a higher-end cable will be backward compatible with lower-spec ports and devices. The ultimate goal of USB-C is to create a seamless, universal experience where you truly can use one cable for nearly everything. As the underlying protocols continue to evolve with standards like USB 4 version 2.0 and Thunderbolt 5, we'll see even faster speeds. Encapsulated within that same compact, reversible connector. The initial complexity is merely a symptom of its immense flexibility, a temporary growing pain, as it absorbs more and more functionality from other legacy ports. The true genius of USB-C is not just its physical form, but its unparalleled adaptability as a universal framework for future-proofing our technological connections. It's a testament to engineering that a single physical design can contain such a dynamic and powerful ecosystem of communication. The future of connectivity is undoubtedly USB-C, and by understanding its nuances, you can fully leverage its potential. If you found this dive into USB-C helpful, consider exploring our other videos on demystifying everyday tech. Stay curious. This is AI Unpacked.